Hello, I'm Mike Knupfel, and I'm here today to talk to you about something I like to call the embedded book. The embedded book is just a name that I made up. It's a combination of the term embedded system and the word book. We all know what a book is. It's got flat pages with text, written or printed, illustrations, photographs, images, and all those pages are bound together. Now for the other part. An embedded system, according to Wikipedia, is a special purpose computer system designed to perform one or a few dedicated functions. So in the case of my project, the special purpose computer will be placed inside the book to make the book move, light up, change, and react based on physical interactions with the reader. So you may be asking yourself, how the heck are we going to fit a computer system inside of a book? I don't think that's going to fit in there anytime soon. We're going to need a different type of computer system. So how are we going to fit a computer into a book? Well, here's the answer. It's an Arduino. It's a tiny little computer. So the Arduino is an open source electronics prototyping platform based on flexible, easy to use hardware and software. It's intended for artists, designers, and hobbyists, and anyone interested in creating interactive objects or environments. So it's going to be perfect for our book. So this is a Boarduino. It's based on the Arduino development platform. And I got this one from Adafruit Industries. It comes in a little package like this. It's like 20 or 30 bucks. And it's got all the components that you need, all the resistors and capacitors, and then the chip. And what you're going to do is you're going to solder this all up together, following instructions, of course, and you're going to have your finished Boarduino. So once you've got everything all soldered up, you take this USB cable and you plug it in right here. And the other end is just standard USB. Plug that into your computer, and you can write little programs in C to control the input and output pins on the Arduino. So I've made a few modifications to the Boarduino. I've put these 90-degree pins here, so that allows it to be a little bit flatter profile. I've also put the voltage regulator and the capacitors in this sideways orientation so that we can fit it into something flat like a book or a book cover. As we said before, the USB goes in here. These connect to your power source, and then these are your input and output pins, and they're going to go to your LEDs or your sensors or your pager motors or whatever else you want to hook up inside your book. So I started working on this embedded book as a project in school, and when I started I didn't really know much about electronics, and I certainly didn't know anything about bookmaking. Okay, so here's the book, or what's left of the book that I made for that class. It doesn't work anymore, but it can give you a good idea of what I was going for. So when you open it up, you've got the clues here, and you've got a family tree on this side, and it's a puzzle. You've got to follow the clues and put the members of the family in the position that they're supposed to be in. Each card's got metallic tape on the back that's in a special orientation that's unique to each card. So for example, Henry, he's got these two strips, and they're connected by another metallic strip across the middle. So this allows a circuit to pass through this pin, through the back, and into there. Because of the way the clues are written and because each card is unique, there's only one solution to this puzzle, meaning that there's only one way that you can put all of these cards into the correct position to solve the puzzle correctly. And when this book was in its functioning form, when you put all the pieces in the correct spot, these little LEDs up in the corner would blink, signifying that you had successfully completed the puzzle. So here's the back side of the book. We've obviously cut out space out that we can put the electronic components in. Here I've got a 555 timer chip, which allows the LEDs to blink on and off when the puzzle's solved. And it went in here, and it was wired up to the LEDs. We've got a little on-off switch here, and to power it, we've got these little coin cell batteries. So while this book worked, and I got a passing grade in the class, it's far from my vision of what the embedded book could potentially be. One of the main problems I had was that I had absolutely no bookmaking technique whatsoever. I've got foam core as the board, binding board. I've got manila folders as pages, glue stick, and tape. It's far from archival. So I made the original embedded book about a year ago. Since then, I've been trying to get better at bookmaking techniques. And so I took a bookmaking class, a Saturday class at City College San Francisco. sort of got me up to speed in many of the basic bookmaking techniques. I've got my yes paste, I've got my PVA glue, learned some Coptic stitch, Japanese post binding, got some pamphlet stitch, and a bunch of other bindings. So I'm certainly not an expert, but I think I know enough now to make the book that I want to make. So another problem I had in this original book was making reliable electrical contacts with thin, flexible materials. So since then, since I made this book, I've been really trying to research other materials that I can use to make those electrical connections. So I've been hitting the craft stores and looking around the internet for interesting conductive materials that I can put inside my book. So how do we know if something will be a good electronic conductor? Well, here's the answer. It's the multimeter. It's our secret weapon in figuring out whether or not something will conduct electricity well. All right, so we take the multimeter, we switch it to measure resistance in ohms, and then we take these two leads, and if we put it on something conductive like this conductive thread, you'll see that the resistance is very low, 0.6 ohms, 0.7 ohms. But if we take it and put the two leads on something that's not conductive, like this football, put the two leads on there, and we'll look on here, and we'll see that, in fact, it's not conductive. So in my search, here are some of the interesting materials that I found that were conductive. Here I've got conductive thread, which is just like any other kind of thread. You can sew stuff with it, or you can stitch it into a book, and it's actually conductive. So it's just basically like a wire. It can carry electrical current through it. So that's pretty interesting. I got this off of Sparkfun Electronics. Some other things. This is aluminum tape. It's in a roll, sticky on the back. I've got a bigger roll here. I've also got some other things like these brads are conductive. This is, I don't know what this is, but it's conductive. And these little tags these metal rim tags, these are also conductive, and these are actually pretty useful. And then also these little button snaps. I've put these into a book here, and you actually can snap connections together like that, so that's kind of cool. Some things that aren't conductive are things like paper, tape, cardboard. You may be saying that's pretty obvious, it's not conductive, but it's good to test things anyways. I've got this wire here, and I thought it was conductive. I didn't test it, and I brought it home, and actually it's got some kind of weird coating on it, so it's not conductive.